Welcome everyone. In this lesson we're going to be looking at lines and specifically equations for lines and the formula for the slope of a line. So let's get to it. Let's start with the three main equations we're going to be using here. And let's kind of go through each of these and see what makes up the equation. So the first one we're going to consider we call the slope-intercept equation. And it's written as y equal to mx plus b. So in each of these first two equations, these give us the equation for a line. And the y value and the x value in each of these is the variable. So we'll keep that in mind as we look at these. Kind of the plane y and the plane x that we see here in all two of these equations, these are just variables. Okay, well, what else is in this first equation? We have this value m, that's kind of multiplying this x, and m is special. M is the slope of our line. And then we also have this other gadget, this other value over here, this plus b that's off by itself, and this is the y-intercept. So this gives us information where our line crosses the y-axis. And so sometimes we also call the point, if we're writing that as a point, it would be the point 0, b. So the value b here tells us kind of where along the y-axis we cross our line crosses the y-axis. Okay. Well, we also have the point slope equation, which kind of generalizes things a little bit for us. So we still have our slope, but now we have these two x and y values, x1 and y1. And so in this case, this is just a general point. x1 comma y1 is just some point that sits on our line. So we would start with the slope-intercept equation if we knew the slope and if we knew where it crosses the y-axis, and we would probably start with the point slope equation if we know the slope and we have some just kind of general point that we know that's on our line. Now the slope-intercept equation here is usually what we would get down to if we simplify the point slope equation. So if we were to say distribute the x or distribute the m and then add y1 to both sides, we would get it down to this slope-intercept equation. So this one's nice and simple to work with. The other equation here tells us how we could actually find the slope of our line. And for this, we need 2 points. We need to know 2 points. So x1 comma y1 is 1 point, and x2 comma y2, it would be a second point. So we need to know 2 different points. In order to get our slope. Nope. Not on the slope, on the line. There we go. So we need to know 2 different points in order to figure out our slope. And when we use this formula, let's read through it. It says m is equal to the change in y, so y2 minus y1, divided by the change in x, so x2 minus x1. And when we do this, the order doesn't really matter as long as we're consistent. So we just kind of have to match things up. The 1 point has to kind of line up like this, and then the second point has to kind of line up like this, and we have to be consistent with the orderings. So if we start with the y coordinate from our second point, well, then we have to start with the x coordinate from our second point, and then go on and subtract in each of those. And then two special cases for lines that kind of fit these descriptions. They do, but they're more special cases, and they are horizontal and vertical lines. So for a horizontal line, this is of the form y equals b, and what happens is our slope is equal to 0. And then we have also vertical lines. And this is x equal to a. And these lines have an undefined slope. All right, so just a couple special cases there to keep in mind. All right, so let's look at a few applications of and interpretations for what these different linear equations or lines, what do they tell us? So let's look at an example. We're going to suppose that we're a manufacturing company, and we find that the total cost of producing X units of some commodity is 2x plus $1,000. And so we want to know, if this is our total cost function, well, what does the y-intercept mean? So what does this plus 1,000 mean? And what does the slope? What's the interpretation of that slope? So our cost function here is this cost function is written as a line. It's a linear function. It's that form y equals mx plus b. So if we kind of just keep that in mind, we're looking at a linear equation, y equals mx plus b. Let's think about what the slope the intercept means. So let's start with our y-intercept. Think about what that represents. Well, if we kind of match these up, we can see that the number in front of the x is the slope. So our slope here is going to be 2, and our y-intercept is the kind of the number that's all by itself. So our y-intercept here is going to be 1,000, and then our slope is going to be 2. All right, so what does the 1,000 represent? Well, this is the cost of producing 0 units. So if I had this linear equation and I were to plug 0 in for x right there, or if I were to plug 0 in for x here, I'd get 2 times 0, which would cancel that out, and I'd have the 1,000 left over. So if I'm producing 0 units, this 1,000 would be my cost. And that represents what we call the fixed cost. So this is the fixed cost is kind of all the overhead costs that we have to pay out regardless of production level. So this might be things like machinery. If we're manufacturing something, we're going to have the machinery before we can start producing anything. It'd be like the buildings. So we're going to have somewhere to work before we can start building anything. So it's things like this. Now, what does the slope represent? Well, the slope is the cost of producing each additional unit. So if I were to say I was producing 100 units and I wanted to know how much would it cost then to manufacture 101 units of this commodity, well, that additional item would cost maybe $2. And so we call that the cost of producing each additional unit. We're going to give that a special name, which we call the marginal cost. So that the marginal cost tells us how much extra we would have to pay if we wanted to increase our production by one additional unit. All right. So when we look at this linear equation, this y equal to 2x plus 1,000, the slope, is our marginal cost. And the 1,000 is our fixed cost. All right. Let's kind of look at another scenario, just to get a little practice. And we're kind of starting off with some economic examples here. All right, so let's look at example 2, and we're going to see the value y of a piece of equipment x years after its purchase is given by this equation y equal to 500,000 minus 50,000 x. All right, so again, let's think of it in terms of, let's kind of reorder things in our equation. So we want to keep our example in mind where we have y equal to mx plus b. So I like to have this is a good form as it's written, but so that we can see this, I'm going to take this x term and we're going to move it in front, just so that we kind of match up with the ordering here. So I'm going to rewrite this as y equal to negative 50,000 x plus 500,000 x. And so we're going to kind of answer the same question. Well, what does the y-intercept mean and what does the slope mean for this linear equation? And we can tell this is a line because it matches up with our slope-intercept form here. All right, so let's start up with our y-intercept and our slope. And again, we're going to kind of match things up. So the number in front of the x, that's right in front of the x there, that's going to be our slope. So we find the whole number that's in front of our x, so the negative 50,000. So our slope is negative 50,000. And then our y-intercept, well, this is the number that's kind of all by itself. And we see that here it's this 500,000. So the y-intercept for this one is going to be 500,000. All right, so what's the scenario here? Well, we're purchasing this equipment, and X represents the years after the purchase. So if we were to plug in X equals 0, so if we were to plug in X equals 0 into this equation, that would be that would be the value of our equipment 0 years after the purchase price, or after its purchase. So 0 years after its purchase, well, that's when we first bought it. So the y-intercept is the initial value of the equipment. So essentially what we've done is we've looked at the value of this equipment after X equal to 0 years. So right when we bought it. And we can see here that the initial value is this $500,000, so probably $500,000 or something like that. All right, so what is the slope? Well, we said the slope was this negative 50,000. And so this value tells us how much value our equipment is losing each year. So, for instance, if we were to plug x equals 1 into this equation, we would get 500,000 minus 50,000 times 1. So we get 450,000. So what that's telling us is after 1 year, the value of this equipment has decreased by 50,000. And so this slope is telling us the rate at which the equipment is changing in value. And the fact that this is a negative slope tells us we're decreasing. That's going to be an idea we're going to come back to. So essentially what's going on is over time, this equipment is losing value. And we call that depreciation. So economics has a special name for something like that. And especially when it comes to taxes. So depreciation allows businesses essentially to regard equipment as decreasing in value or depreciating. And so they can, usually there's some income tax deduction for that loss of value. It's called depreciation. All right. So let's kind of take a step back from these examples and look at just one more for now, and then we'll continue on during class time. So let's look at example 3. So in this example, we're gonna find the slope and the y-intercept for this line. And the way this equation is written, it's not immediately in the form y equal to mx plus b. So right now, we do have the 2x. That's okay. We have this constant that's all by itself, but it's on the kind of the opposite side of our equal sign here. And then we also have a constant in front of the y. So it doesn't quite match up just yet. So we always want to kind of think about this y equals mx plus b form. And we want to get it into that form. So the first thing we probably should do is, well, let's get all the y term, let's keep it on the left. So we have our y term here, we have our y term here. Let's just keep those on the left-hand side. And then anything that doesn't have a y in it, let's move those over to the right-hand side of our equation. So to do that, we're only going to have to move this 2x. So I would subtract 2x from both sides. And that's going to give us 3y is equal to 6 minus 2x. So we could write it like that. Or, kind of like we did in the last example, we could switch it around and put negative 2x first plus 6. Okay. Well, now we have this 3 that's in front of the y. We got to get rid of that because in our form, it's just a y. So this 3 is kind of causing us an issue. And so the way to get rid of that 3 is we're going to divide both sides of this equation by 3. And so when we do that, the 3's cancel over here, kind of by design. So we're going to get y. And then when we have a fraction like this, where we're dividing everything by the same number, well, we can really split that fraction up into two separate fractions. So we can get 6 over 3 and then minus 2x over 3. And if we simplify this down, we get y is equal to 2 minus, and when I write this negative 2/3 x, I'm just going to kind of break off the constant term here from the x term. Just kind of separate them out. So when I'm looking at this, I kind of keep the negative 2/3 separate from the x. So I'm going to write this as negative 2/3 times x. And once we have it in this form, we can tell what the slope and the y-intercept are going to be. So the y-intercept is just the number that's all by itself. So in this case, it's the 2. And then the slope is the number that's in front of the x, so negative 2/3. So we just had to, in this example, we just kind of had to manipulate the starting equation in order to get it into that y equals mx plus b form. And then from there, we were able to kind of identify the y-intercept and the slope. All right, so we're going to stop there, and we'll kind of pick up with the notes here in class. So we'll see you then. Bye-bye.